Okay, so we're going to go back to the animal, and we're going to talk more about exception handling. So I know that we discussed it to deal with the invalid animal exception, but there's a whole bunch of other exceptions we should be dealing with. So these are the things where the programmer has made a mistake. So there's no rhyme or reason to it. I'm just going to start at the abstract animal. So there's a few things that could be wrong with the abstract animal. So the thing I'm going to be checking is the parameters. So I don't want the name to be null, for example. And that's in the programmer's control, right? The programmer is the one calling the method. They can make sure that they don't pass in null for the name. So that is an illegal argument exception. Right, and it just tells the developer that name can't be null. And I'm going to do the same thing for the number of legs, same idea. And it's an int, so it can't be null, but I don't want it to be less than 0. A snake has no legs, so 0 is fine. You could be a person with no legs. You've had 2 amputations, for example. But you can't have -1 legs. That doesn't make any sense. So if we wanted to say you can't have more than 1,000,000 legs or something like that, we could put that in there too. So this has to be num legs cannot be less than 0. And I'm going to say it was. Numlegs, so that they know what it was. Oh, it's -2. Now they can search around and try and figure out where did -2 come from. Set name. Okay, I'm going to show you something that you may have been taught in your courses. Some people would do it this way. That's wrong. I already explained to you why that's wrong, because of the inheritance and all that, right? This could wind up calling a method that's overridden by a child class, blah, blah, blah. So we can't do that. We can't call one of our own methods. So that's not okay. But what I also don't want to have to do is the same kind of validation in 2 places. So I thought about this for a while, and we decided on this. And you could put these inside of a utility class if you wanted to, but I'm just going to put it in here for now. So here we can say if the stir is equal to null, then I can't hardcode this to be an m, so what I actually need to do is pass in the variable name too. So I'm going to call the check string not null or empty, passing the variable name like nm and the actual value. So here, I'm not only going to do this, I'm going to do this. Don't worry about this, it's just IE telling me that it's always nm right now. So it's telling me I don't need this as a parameter, but if I was to use this with other strings, obviously I'd want to have that. So you can see why I'd want to put this in a utility class, and I'll show you how to do that. I'm actually going to, I think I should be able to do a refactoring actually. So refactoring again is just changing your code to make it work better essentially. So I would like to nothing that I want to do here. So what I want to do is extract it to a separate class. So I'm going to make this a new Java class called checks. Now, I'm going to make this class final because I don't want anyone to extend from it because it's all going to be static methods, so no point. Because it's all static methods, I don't need to make an instance, so I can make the constructor private. Now, nobody can call it except me, and as we all know, I do silly things all the time, so I'm going to throw a new illegal so state, not access. I could say it's an access thing. So I'm just trying to see if there's anything really good. State is probably the closest I'm going to get without creating my own. Right, so I'm just reminding myself, don't do what I just did, right? So don't ever call new checks. So final class can't be extended from. Private class also can't be extended from, but so the final is redundant. But, and the reason why it can't be extended from with a private constructor is that if you have a private constructor, nothing, not even a subclass can call it. So you can't subclass it because you can't call the one and only constructor. Final makes it a little more clear because somebody's like, oh, cool, I could extend that class, and then find out you have a private constructor. So marking the class as final makes it so that you have no choice, right? It's really clear right from the outset. So we have this, thing here. I may as well, while I'm here, add another one saying check int greater than. So if the value passed in is less than or equal to the minimum, greater than or equal is what I actually want in this case. And you don't have to be this verbose. You can be this verbose, your choice. I mean, I could even go one step further, greater than or equal to, right? So it's, reads like English. So if the value is less than the minimum, and that should be an int, not a string, then the math will work. So var name cannot must be greater than or equal to. Now, this is why you see I use the string format, because this winds up being a whole bunch of pluses and all that, and I don't want to do that. So what I'm actually going to do is string.format %s must be greater than or equal to this integer was this other integer. And it's going to be, the var name is going to become the %s. The value is going to become this d, the min. Right, so what I want to say is that the numlegs must be greater than or equal to 0 was -1. So that's why we have this string format, because now I can read this a lot easier, and you don't have to deal with all the pluses with the starting at the string again. It gets all really confusing. So the question is, do I want to be consistent, so I'd put the var name and then the value. I'm going to call this value for consistency. Now I also said not null or empty, so I should actually check for the empty part. Now, I don't like doing this. Okay, I'll finish off the throwing the exception. So here I've got multiple things with dots. I don't like that. Also, if I wanted to see what the result of the trim was, I don't have a way to do that in the debugger easily. So what I'm going to do is final string. Oh, and I don't like the way I named that, so I'm just going to go refactor, rename, and call this trimmed value. And notice it changed it here and here. So now I can use trim value. And makes my life a little easier. I still don't really like having the dot length, but in this case on the string, I know if I'm in the debugger and I hover over this, it'll tell me what the actual string is, and I can see it, so it's okay. So what trim does is it takes care of all the white space on the left and the right of the string. So if you passed in a completely empty string, or a string that's just a space, or whatever, and I think I did this already in the tic-tac-toe game. So you've seen that already. And there's better ways to handle that. I'm just doing a very simple way. So I want it to be consistent, the variable, the value, the variable in the value, and then the information about it. So this is information about the variable too, so I'm actually going to switch this around. But I'm not going to do that. Because of the way I name things, right? Check that the int, well, I expect that to be value, is greater than or equal to, and I expect it to be the other value. If you do Swift programming, they do a really cool thing. So I'm not going to tell you about it, but they do really cool things with the naming, and basically the variable names form part of the signature. So it'd be check, and you'd have the word int here, value, whatever. So it's check value greater than or equal to, and the number shows up here, but you can't describe it without seeing it. But it's really cool. So Swift for that rocks. So we've got our abstract animal over here, and this should be checks dot. And this should become checks dot check integer, and the name is numlegs. Nope, not numlegs. It's numlegs. Right? And the value was numlegs, and we want it to be greater than or equal to 0. So all that so that I can just do the same check here, right? So we don't want to call, and I'm going to put a space just to show that they're separate. All that so I don't have to call set name from within my constructor, because that's a horrible idea. So that's cool. Get name, we don't need to check anything. So animal, it's an interface, don't need to check anything. Animal factory, interface, don't need to check anything. Bird, okay. So ultimately the bird constructor calls the parent constructor no matter what, and the parent constructor we already saw did the actual work, so we're good there. Same with cat. Okay, so here comes another interesting design thing, and this comes up quite common. So I want to check that the message is also not null. I don't know why I want to check that, but let's say I want to check that. It's a decision that you have to make. Should this message be allowed to be null or not? Now I'm going to have to do that in cat and in bird, all over the place, right? And I've got this parent class. Parent class is really cool. I like it. Lets me reduce my work. So I'm going to go into the abstract class, and I'm going to make a final method. Aha. So a final method means it can't be overridden, which now means bird has a compile issue because it can't override that. We'll come back to that. So I want to do the same kind of thing, that the message is not null or empty. See how much easier that is? Less tedious all around. And all the checks will now be consistent too, all the messages I put out. So I want to print out chirp. I validated that, so now I'm going to call do speak, passing a message. And I'm going to make do speak an abstract method. So we're gonna call speak, and it's gonna call do speak, which is the overridden one, but it'll only call do speak, assuming message wasn't null or empty. So that's awesome, because now all I have to do is go to bird and change this to protected and change this to do speak, and we're guaranteed that the do speak method, the message, will never be null. So go to cat and do the same thing. We can go to dog and do the same thing. Because here, see, this would have crashed, right? Message dot equals, well, that's null dot equals. That would have crashed. Now we're able to tell that that can't happen. Invalid animal exception. We probably don't want to deal with the string being null here. We could if we wanted to. Throwing an exception when creating an exception is kind of weird. I just want to go to wolf over here. So this one we'll also need to do, because remember it was implementing the animal, so it doesn't extend from abstract animal, therefore it doesn't have anything to do with do speak. So we're going to want to steal this thing here. Okay, and the same goes for this constructor here in the set method. It's actually, remember we actually stole all of this pretty much from the abstract animal. So we can go to the wolf and we can go to the set name as well. So you can see with the wolf the power of inheritance, because the wolf didn't extend the class, it only implemented the interface. And that means that it didn't get the benefit of all the extra code. So now it has to duplicate that. Not horrible, but not ideal, right? So this is why we want to use inheritance. So the random animal factory. So the animal type, well, same thing. The animal type can't be null or empty. And that's the only, I'm just validating my parameters. And I should also make sure that all my if else's and all that have an else. And that's okay, because we also made this final, which means if we screwed up, say we didn't assign this, this won't compile because it'll say animal hasn't been given a value. It actually doesn't even matter in this case if it's final or not, because it'll still say animal hasn't been given a value, because that's the way Java works. But there are cases where that doesn't happen. So making things final is really good. And the cases aren't inside of here. The cases are when you have a variable outside of here. But marking things as final, really, really helpful. The reflection one, same thing. We're going to want to check for that. Oop. We need to check for the animal type not being null or empty, because again, we're using it here, and null there would be horrible. We don't need to do any of those checks for these things, because again, they threw exceptions. And there was a default animal factory, and it had the same kind of thing. You could notice, I always put my variables at the top. You would hopefully remember that this one doesn't actually use the animal type. This one's debatable. You might choose to call this ignored. And since it's ignored, we don't have to check it. So we're calling it ignored because, oh, no, sorry. My mistake. Wrong class. Animal type. In the random animal, we can call this ignored. And not have this check. Put the check back in here? Yes, it did. Because we're not using the string. So there's no need to check it, and we can call it ignored because we are ignoring it. Your choice if you wanted to call that ignored. I wouldn't. But you could. That's a stylistic choice I leave up to you. So yeah, so it's just a simple matter going, and it's better to do it up front than rather than doing it later. But it's looking at all of your parameters and thinking about what are the possible things that somebody could do wrong. So I could pass in a string that has nothing in it. I could have pass in a number of legs that are like insane, like -1 or 2 billion. Maybe that's perfectly fine. I don't know what you have 2 billion legs for. Maybe that makes sense for your use case. But if you only wanted to have up to 4 legs, then set your thing to have at most 4 legs. So you're making a video game and you've got people and you've got horses, right? And that's it, nothing else. Then you can say the legs have to be 2 or 4 and nothing else is valid. And you can write a check for that. So you just have to think for what you're doing, what do you want to make sure things are set to be. So yeah, and then wherever possible, move everything up into the parent class. So we noticed that we were doing this same line every time, just this one. And rather than have to remember to do that each time, it was more convenient to make the method up in the parent class, make it final. You don't have to do this, but if you make it final, people can't override it, so you're enforcing this behavior. This is what's called the template method. So the template is speak, first checks to make sure that the message isn't empty, and then it defers the behavior to the child class. So this is a relatively common thing. If you do the enterprise Java stuff, you can't mark this as final. But that's, at least I don't think you can. I try and stay away from the enterprise stuff personally. But yeah, so I think that deals with exception handling. So you've seen checked exceptions, you've seen unchecked exceptions, and you've seen the kind of things you want to check. So remember that checked exceptions are for things that you, the programmer, have done wrong, right? So that was in the animal factory, right? We passed in snake, and we haven't handled the snake. Well, I expect somebody to pass in an animal that isn't valid. That actually does lead to another design consideration you could make. You could have another method called isAnimal that takes the string animal type and it returns true or false if it is actually one of these things. Two schools of thought. If you're going to throw an exception, you should always make sure that somebody, if they can reasonably have a chance of seeing if the exception would be thrown if they called the method, to avoid that from happening. So it's a way that some people deal with things. So you can catch the exception if it went wrong and then report back to the user, or you could make it so I never even call the method. Personally, I just stick with this one. It's rare that I do the other way, but it happens. There's one broken case in the JDK that I do not like in the Java developer kit, and that's integer parseInt. So if you look up integer parseInt, and we pass in hello, that compiles just fine. But at runtime, you'll see that it says there that it throws a number format exception. Number format exception is a runtime exception. That means you're not supposed to catch it, which is fine. However, they haven't given you any method to say, will this parse as an int? Now, this might have changed in more recent JDKs, and I'm not aware, but for years at least, and as far as I know to this day, they don't have a simple method that just tells you, will this successfully parse as an int without throwing an exception? And it's not really needed if parseInt had a checked exception, but they did it as an unchecked exception. So my choices are catch number format exception, do this in a try catch that catches number format exception, but I've told you don't do that because that's not what the compiler is going to tell you to do. The other alternative is to write your own code that checks to see if it's an int before you call parseInt. I really wish that they'd made parseInt throw a checked exception. I don't know why they didn't. It could have been that a long time ago when they first started this, checked exceptions weren't a thing, and then they added them later. I don't really know the history of it that well. But that's believable. Or it could just be that in their particular use case, they didn't have it, it wasn't convenient for them to have it as a checked exception. So there's a whole bunch of things. But you should really think about, okay, if I'm going to throw an exception, I need some way for a person to easily be able to tell if they're going to violate it. So in this case, it's easy to write a check beforehand to see if it's null or empty. It's easy to check to make sure that we're not passing in something less than 0. It's a lot harder to expect people to write all the code all the time to check to make sure that they've got a bird, a cat, a dog, a wolf, and nothing else. So we should consolidate that somewhere. I've chosen to do it by throwing a checked exception that tells you when you've done it wrong. So basically, you can assume whatever you were given was correct and then find out here it was wrong. That may not work out for you, in which case go ahead and write another method where you give it a string and it returns true or false if it's a valid thing. And we'll actually be able to see that later on once we've covered collections. Because we're going to rewrite this code to use collections, and this will become very small, like one line kind of thing. But we'll worry about that another day.